Okay, we'll get back to section 11.5 here, and we'll finish up this section in this video. All I had was two more examples left of using the alternating series test. And so let's take a look at this next one here. We got the summation as n equals 2 to infinity of cosine of n pi divided by the square root of n. Okay, now n is only going to be counting numbers, right? So 2, 3, 4, 5. So cosine of 2 pi, that'd be 1. Cosine of 3 pi, that'd be -1. Cosine of 4 pi would be 1. Cosine of 5 pi would be -1. So I'm just going to be bouncing back between 1 and -1 each time in the numerator. So I can rewrite this summation up top as -1 to the n. Now I want to make sure I'm matching up term by term here. So when n is 2, -1 squared is 1. When n is 2 right here, cosine of 2 pi is 1. When n is 3, -1 cubed is -1. When n is 3 here, cosine of 3 pi, that'd be -1. Okay, so this series is the same thing, right? Now, so the idea is to recognize this as an alternating series. And there's two conditions that have to happen when we use the alternating series test. Okay, so the first thing, I'm going to check that the limit as n approaches infinity of the sequence a sub n, which is 1 divided by the square root of n. So I ignore the alternating term, the -1 to the n. That's 0, right? Because the denominator is going to grow without a bound as the numerator just sits at 1. So the y values will be getting closer and closer to 0. Okay, and the n plus first term is always going to be less than the nth term for values of n that are 2 or more, right? So that's the interval that I'm on. Okay, and the reason why that is because, if I add 1 in the denominator, the overall denominator is going to be some bigger number compared to the right side. And the overall fraction on the left would be a smaller number than if the number in the denominator is bigger. Okay, so the n plus first term is always going to be less than the nth term for values of n that are greater than or equal to 2. So we have a convergent series. Okay. Let's take a look at this next one here. So I got the summation as n equals 0 to infinity of -1 to the n minus third power times the square root of n divided by n plus 4. Okay, now notice that in this case, the exponent on -1 isn't n or n plus 1. That's not going to matter. I still should recognize this as the series will alternate terms. Okay, so if n is 0, -1 to the negative third power, that'd be -1. If n is 1, -1 to the negative second power, that'd be 1. If n is 2, -1 to the negative first power, that'd be -1, right? So I'm still going to have an alternating sequence is the point with that. So I can use the alternating series test. Okay, so use these two things here. Now the first condition, this limit calculation, that's going to be easy enough to check with this guy here. So the limit as n approaches infinity of the square root of n divided by n plus 4. If I multiply the top and bottom by 1 over n, of course I don't want to multiply something where the denominator is going to be 0, otherwise that's no good. But if we use 1 over n, the square root of n divided by n, that's 1 over the square root of n up top. And then multiply n plus 4 by 1 over n, and you get 1 plus 4 over n down under. Okay, limit as n approaches infinity of 1 over the square root of n, that's 0. And you're dividing by 1 plus 0 is 1. 0 over 1 is 0. Okay, so that condition is satisfied. Okay, so I checked the limit calculation. Now the next thing I have to know is that do the terms decrease? Is the n plus first term less than or equal to the nth term? Okay, well the second condition is going to require some work because it's not immediately clear that the terms decrease. You know, so we're going to resort to Calc 1 methods to show that the terms decrease. Okay, now up here and in these other couple of examples, I was very easily able to show that you know, the n plus first term is less than the nth term, because like right here, you know, the denominator is going to be a bigger number, and so you can easily see that the overall number on the left is going to be a smaller number compared to the one on the right, because the number in the denominator is going to be a bigger number. Okay, now in this calculation, I have both the numerator and the denominator are changing, so it's not very easy to see that. You know, do the terms decrease or not? Okay, so we're going to use Calc 1 methods here. We got to show that the terms decrease. Okay, well, if we have the function f of x equals the square root of x divided by x plus 4, okay, then let's see, f prime of x, using the first derivative test, that'd be a quotient rule. So the bottom times the derivative of the top is 1 divided by 2 root x minus the top is root x times the derivative of the bottom, that's 1, all over the bottom squared. Okay, and let me get a single fraction up top there. So multiply by 2 root x. 2 root x times root x is 2x. I'm subtracting 2x. And I got x plus 4 minus 2x up top, and then 2 root x down under. And I'm dividing this by x plus 4 squared. It's actually x plus 4 squared divided by 1. Right, because the next thing I'm going to do is I'm going to flip the fraction down under. And let's see, x minus 2x, that's minus x. 4 minus x divided by 2 root x times x plus 4 squared. That'd be as simplified as I can get it. Okay? Now, I'm only concerned about what's happening when x is not a negative, right? Because the series is starting at 0. Okay, not anything negative, right? So, let's see. Well, when is this less than 0? Well, the denominator is always going to be positive. For no matter what x is greater than 0. X can't be 0 here. But the denominator will always be positive, you know, for values that are bigger than 0. And the numerator, let's see. So if I let 4 minus x be less than 0, well, that's going to happen when x is bigger than 4. Okay, so the terms won't decrease until I'm after 4. Okay, now, so x greater than 4 means that f prime of x is less than 0. We said that, right? So f would be decreasing on the interval 4 to infinity. Okay, now, in this condition, all we need to know is, do the terms eventually decrease? Like, it's okay if they don't immediately decrease, but do they decrease then, you know, at some point, and then decrease, you know, forevermore after that? And the answer would be yes. Okay, it'll happen here. So you're decreasing everywhere after 4. Okay, so the n plus first term, which is the square root of n plus 1 divided by n plus 1 plus 4 is n plus 5. That's going to be less than or equal to the nth term, which is the square root of n divided by n plus 4. Okay, this statement would happen when n is greater than or equal to 4. Okay, so the terms do decrease eventually. You know, it doesn't happen at 0, okay, right off the bat there. But I'm starting this at 0, right? It does not happen right off the bat, but, you know, it eventually does happen when you're after 4, though. Okay, so let's see, the two conditions are satisfied. Therefore, I got a convergent series. Okay, the summation as n equals 0 to infinity of -1 to the n minus third power times the square root of n divided by n plus 4, that series converges by the alternating series test. Okay. All right, so here's homework problems that I'd like you to look at in this section. I'll go ahead and start section 11.6 in the next one, next video there. Now, in section 11.6, we're going to talk about 3 things, and these 3 things are going to be the last tests that we'll need to know before we kind of put all this together, and then in section 11.7 now there's going to give us a series, and they're no longer going to tell us use the alternating series test or use the integral test or whatever. It's like we'll have to figure out on our own what test is going to be appropriate for that particular series. Okay, and I'll mention some things to look for in those problems. Some things that would be like a go-to test type thing there. Okay, so we'll stop the video right here though.